So hello everyone, welcome back to our channel Known for Knowledge. Yes, hello everyone, welcome back to our channel Known for Knowledge. So today we are going to learn about the first lesson of science. That is, what is the first lesson of science? That is chemical equations and reactions. Is the first lesson of our subject, the science, right? So in this lesson we are mainly going to learn about different type of chemical equations and their equations, and then we are going to learn about different reactions, and we are also going to learn about their equations also, how to actually form an equation, and everything we are going to learn in this first chapter, that is chemical equations and reactions. So this is a very important chapter from the examination point of view, because the questions which are going to be asked are going to be very simple, because you have to just remember all the equations. So if you just remember all the different kind of equations, then you can easily answer all the questions which are asked from this lesson. Okay, so let us start with our first lesson. So before we actually start, let us learn actually what are the physical and the chemical changes. So what are actually the physical and the chemical changes? Physical changes are the kind of changes wherein I'll write right here. Physical changes are the kind of changes which are reversible. Reversible in the sense that once they're actually forming, turning into another substance, they can actually be we can actually get back the same substance again. Okay, that is a physical change. If you see the physical changes, I'll try to write the physical changes. So physical changes. In this physical changes, we try to see that no new substance is actually formed. For example, if you take the melting of candle. So if you take the melting of candle's wax. If you see, it is in the solid form. So when we actually burn the candle, when we actually burn with the help of a matchstick, what happens? The candles will actually melt into wax, right? So this is a wax which is actually formed. So again, when actually that wax will actually solidify, when actually it will cool down after some time, again it will actually form the candle, same thing, no? So what you're actually trying to see, that here no new substance is actually forming. Here the same substance is actually changing its form. That's it, but no new substance is formed. That is the physical changes. Okay. Then what are actually the chemical changes? Chemical changes are the kind of changes wherein we try to see that a new substance is actually formed. For example, you take a paper and you try to burn the paper. What is happening to it? It is getting, we are actually getting a new substance, that is ash. So that is the chemical change. So chemical changes is the burning of a paper. So that means burning of paper. So in the burning of paper, we are actually getting a new substance. Therefore, they are considered to be the chemical changes. And chemical changes are considered to be irreversible. Why they are irreversible? Because, for example, if, as I already told about this burning paper, can you we get the when it is actually burned, we get the ash. So can you convert the ash to again the actual paper which was there before? You cannot get it. Therefore, they are considered to be the irreversible changes. Therefore, first you have to remember what are physical changes and what are the chemical changes. So in this chapter, we are mainly going to see those kind of chemical changes which are not reversible, which cannot be brought back. So those kind of changes we are actually going to see in this chapter. That is the chemical changes. So that means you got an understanding, right? What is actually the chemical change and what is actually the physical change. Now let us try to see as what is actually given in your textbook also. So in your textbook, if you see, a few examples are also given in your textbook. So let us once check what are those examples also. You see the milk. So milk is actually left in a room temperature. Then iron tawa or anything will get rusted when it is actually exposed to the atmosphere. And gates also get rusted, right? So it forms a brown color substance which is called as rust. Okay. Then grapes also get fermented. Then food is also cooked. Can you get back the raw materials, that is raw food, raw particles of the food and vegetables? We cannot get back, right? After it is cooked, right? No, we cannot get back, and that is a chemical change. When food gets digested in our body, can you bring back the first food items which are there before? We cannot bring them back. We cannot bring them back. So that is a chemical change. And respiration also is considered to be a chemical change. Okay. Now let us try to understand first activity which is actually given in the textbook. So what we are actually doing here? So here we are actually taking a Bunsen burner. We are taking this not Bunsen burner. It is a burner we are going to take, and we are actually burning the ribbon. What kind of a ribbon we are burning? We are burning the magnesium ribbon. So why this magnesium ribbon is very much important? So this magnesium ribbon is kind of some silvery grayish color, you can say. So silvery kind of a grayish color, you can say. Okay, that is grayish color. That is magnesium ribbon. Okay. So this magnesium ribbon, when it is actually burnt in air, should always remember, when in chemistry, when we are actually talking about burning in air, it means that it is reacting with oxygen. Therefore, what you are seeing here, so magnesium, it is burnt in air. Burnt in air, it is nothing but it is reacting with oxygen. Why only oxygen gas it is reacting? Why it can't react with hydrogen gas? Because for any substance to burn, oxygen gas is an essential gas. So every substance, in order to burn, as you have actually learned in your 8th class in combustion chapter, combustion is nothing but burning of any substance in the presence of oxygen in order to form heat, light, energy is called as a combustion, right? So combustion is we are actually burning a substance in presence of oxygen. This is also combustion reaction, wherein we are actually burning of the magnesium in the presence of oxygen. So here actually we are burning it. So this is a magnesium oxide that you must remember. Okay. So it is okay. I forgot that. So magnesium, when it is actually burnt in air, that it is when it is reacted with oxygen. So if you see here, the reaction is actually happening. Okay. So after that, what happens? So after that, when it is reacting, it is actually from some few particles of few white color particles are actually falling here. If you see, few white color particles are actually falling here, right? Few white color particles are actually falling. So those kind of white particles is called as magnesium oxide. So when magnesium, that is Mg, is actually reacting with oxygen, then it forms magnesium oxide. So why magnesium oxide? How magnesium oxide is formed? If you see the valency of magnesium valency and oxygen. Magnesium it's 2, oxygen also 2. So crisscross method, Mg2O2. So 2 will cancel, so MgO. So in that form, magnesium oxide is formed. You must remember all the valencies from your 9th class textbook. There is atoms and molecules. You have all the table of valency styles. You must remember them, very much important. Okay. So this magnesium is very reactive in the presence of oxygen. So therefore, just if you keep the magnesium ribbon outside, also what happens is that you'll get a very thin layer of magnesium oxide. So if you think this is a magnesium ribbon, it is in grayish color. It gets a thin layer of thin layer of magnesium oxide. So therefore, we should always clean it before with a sandpaper before we actually burn the magnesium ribbon, because this magnesium oxide which is actually formed on this magnesium ribbon will prevent it from burning. So mostly it will not prevent it from burning because it is very thin. The high, more pure magnesium might actually react with oxygen and forms a thin layer, but mostly it is not like that. You can directly burn it without using sandpaper also. Okay, so that is a white color powder. So as you have seen in the before experiment, a white color powder is actually formed, which is nothing but it is a magnesium oxide. You must remember this, very important first activity. Okay, so they may ask you what is a powder which is formed and which ribbon is actually burned, and which ribbon is actually burned with dazzling light, means it is a magnesium. Magnesium always burns with a dazzling white color flame. So therefore you must never see the magnesium ribbon with your eyes also, because it can actually spoil your eyes also, because the direct sight of seeing the burning of magnesium ribbon can actually spoil your eyes also. Therefore you should never see it also, not preferably. Okay, now let us try to see the second experiment. In the second experiment, we are mainly going to see about so this second experiment we'll try to see it near the double displacement reactions. So we'll remember that, so near double displacement reactions. Okay, then now let us see the this one is see near the displacement reactions. Okay, because if you go there only, then only you'll understand more deeply. Otherwise, if you see now, you'll not understand this reaction of the Mg and everything. You'll not understand now more clearly. So once you actually go into the subject, then you'll understand more clearly. Okay. Now let us try to see how we can actually classify that actually a chemical reaction is taking place with our own appearance. Of course, the exchanging of atoms it is taking place, everything it is taking place, but we cannot see them, right? Then how we can actually tell, by looking at that reaction, how we can actually tell that a reaction is has actually taken place? So first thing what you have to do is a change in state. Change in state is, for example, if you see there are different reactions, wherein first they might be in some kind of a solid state, but they may be turned into some liquid state also. All those kind of reactions. For example, if you take this magnesium ribbon, this is in the solid form, then it is changed into powder form. No? That can also be considered, but that is not mainly considered because powder is also solid only. So you can mostly take the kind of reactions wherein it is actually turning from solid to liquid or liquid to solid, some kind of reactions. Okay, so in most of that will happen in the reactions. Once we actually go into the topic, then you can understand the reactions also. Then changing color, as you can see, the magnesium ribbon, which was grayish in color, it has actually changed to white color powder. That means a change in color. So by looking at the color, you can tell that yeah, this reaction is actually taking place because there is actually change in color from grayish color to white color. So we can use a state, we can use color. Evolution of gas also. So I'll try to do the 1.3 activity wherein Zn, when it is actually reactive with H2SO4, it forms ZnSO4 plus H2. Here hydrogen gas is actually released. This arrow mark indicates that a gas is actually evolved. Okay, so hydrogen gas is released here. That means it is indicating that. So when there is actually releasing the gas of we can say that a reaction is actually taking place. Okay, the change in temperature also. The change in temperature is nothing but when the change in temperature. So that means first the reaction was okay, it was normal. But after we have mixed 2 or 3 products, what is happening? The change in temperature, wherein first it was cool only, but then it is actually changing into very hot. That those kind of reactions can also be considered that. So by looking at all these 4 observations, you can tell that a reaction is actually taken place. And formation of precipitate also. Precipitate. What is actually this precipitate? Okay, what is actually this precipitate? Precipitate is nothing but an insoluble substance. Insoluble substance which is actually formed after the reaction. So this substance, for example, this substance will actually settle on at the bottom of the container. Okay, this is insoluble in nature. This is not soluble. Okay, so by looking at all this kind of that is precipitate, color, state, gas, temperature, you can tell that a reaction is actually taking place. Now let us try to understand what are the chemical reactions. So chemical reaction is nothing but it is a shorthand notation of the reactions. We can tell as the chemical equations. Okay, shorthand notation of the chemical reactions is called as chemical equations. Okay, if you see here magnesium oxygen, magnesium oxide, so you can easily tell because magnesium is the oxygen is the magnesium oxide. But there are actually some kind of equations wherein a lot of thing has to be written. In that case, if you write everything in the word form, it will take a lot of time to write also. Therefore, we use a different kind of thing, that is symbols. These symbols will help us in time saving also, and also help us in understanding the equations easily. Okay. And now let us try. So this side is called as a reactants. Reactants will actually undergo the reaction. Okay. Whereas the product which is actually formed, that means the new substance which is actually formed after the reaction is called as a product. So that means LHS you can say reactants, RHS you can say it as a products. Okay, that you must remember. And one or more reactions. So one or more products are separated by the plus sign, and this arrow indicates the new product which is actually formed. So if you see the reaction here, so if you see, I'll write again here, Mg plus O2 gives rise to MgO. If you see this reaction here, one Mg is there, okay, one Mg is there, 2 oxygens are there, only 1 oxygen is there. So those kind of equations which are not balanced, that kind of equations are called as a skeletal chemical equations. So unbalanced chemical equations are called as a skeletal chemical equations. Okay, if you see, it is given here. That means in that, what is actually the skeletal chemical equation? That means atoms of both the sides, atoms of elements on both the sides, that is left hand side and the right hand side, they are not equal. Then that is called as a skeletal chemical equation. Then we should always balance a chemical equation. So we should always balance. So unbalanced equations must be converted to the balanced equations. So therefore, because they should always be in a balanced form. So you might get a question, why we should always balance a chemical equation? So because mass, so as you have actually learned in the 3rd chapter, 9th class 3rd chapter, Atoms and Molecules, Law of Conservation of Mass, which states that mass can neither be created nor be destroyed in a chemical reaction. Therefore, how we can actually destroy the mass? We cannot destroy the mass, or we cannot create the mass also, right? So this side should be equal. So this side, what all atoms are there, that side also should be the same atoms. For example, if this side 2 oxygen atoms are there, then this side also 2 oxygen atoms should be there. That is an important thing which you must actually remember. Okay. Okay, that is a reason why actually we try to balance the chemical equations. So that is Mg plus O2 gives us to MgO. Okay, that is a law of conservation of mass. That means atoms of elements on the left hand side should be equal to the atoms of elements on the right hand side. Okay, or else you can say atoms of elements of the reactant should be equal to the atoms of elements of the products. Okay, that is the important thing. Then how we can actually balance a chemical equation? Now let us try to see how we can actually balance a chemical equation. If zoom it and video. So Mg plus O2 gives rise to MgO. So there are two ways in order to balance the chemical equations. One way, what is actually given in your textbook, that I'll say, and another which my teacher has actually taught, that one I'll say. So that is a linear method, and this is a normal method which is given in your textbook. This method is useful for all the kind of equations wherein small chemical equations are given. And the other method which I actually tell is going to be very useful for you in calculating the big chemical equations. Okay. So this first you draw a table. LHS, RHS, Mg, what all elements are there that you write on this side? Oxygen. In the LHS, how many oxygen atoms are there? Okay, in the LHS side, magnesium only one is there. Okay. In the RHS side also only one. In the oxygen, two are there. In the LHS side. In the RHS side, only one oxygen atom is there. Okay. Then what needs to be balanced here? If you see here properly, then what needs to be balanced? Here the oxygen atom that is on the RHS has to be balanced, right? So okay, let us do one thing. Okay, we will keep 2 here. Okay, so what happens now? So this is the first step. Second step, what happens? So Mg plus O2 plus, it becomes like this. So do you think this compound will actually exist? No, it will not exist. As you know, when we actually did the crisscross method, so these two actually got cancelled, and this is the only product. So remember, the products, this kind of compounds, we can never change. That means we cannot keep it 2 based on our own wish. So we should not change this kind of the products. That means we cannot add 2 here and here. Okay, we cannot add that one because this compound is existing only as this one, that is MgO only. So we cannot change it as Mg2O or MgO2. We cannot change them. So where we can actually add 2, then where we should actually add 2. So we should add the 2 here. Okay, so we should add 2 near. So where we should, so I'll write it. So we should add 2 near here. Anything you want to add in a compound, you should give it only here. That means here. That means before Mg. So before Mg, you should actually write. Now, if you see here, what happened? What is actually, again we'll draw a table. Mg, 1 is there. On RHS only 2. See, if you see here, this, whenever we actually write 2 in this form, so I'll change the color. When actually we write 2 in this form, this 2 is actually applicable for Mg as well as for O. That means the 2 is actually applicable for both Mg as well as for O. That means for oxygen. Okay. So these 2 here. So if you see oxygen case, oxygen is balanced because here 2 oxygens are there and here 2 oxygens are there. But here Mg case is not same because if you see Mg, one Mg is there, here 2 Mgs are there. Therefore, then what needs to be balanced here? LHS needs to be balanced. So we'll keep LHS also, near LHS we'll keep 2. Okay. Now what will happen to it? Now final box. Which has to be formed. Okay, in this final box you are mainly going to LHS, RHS, Mg, O. So 2, 2, 2, 2. If you see, all are getting 2, right? So if you see here also we have to keep. So final equation I'll try to write here. Okay, Mg plus O2 gives rise. So MgO. This is the equation we have. Then the balanced chemical equation, it is 2Mg plus O2 gives us to 2MgO. This is the equation. That means 2 Mgs are there. Okay, 2 Mgs are there on LHS. Okay, 2 Mgs are also there on RHS. Then 2 Mgs are there in oxygen. And here also 2 Mgs are there. So this is the balanced chemical equation. So what you actually try to understand from this? Means you have to do all these 3 different kind of things. Then only you will actually get marks. Okay. So if they ask you to show specifically how to actually balance a chemical equation, then you should write everything, and you should also explain the process also. Right. You write everything, and you should try to explain the process also. Otherwise, if it is not asked, means they're mostly in the exam they'll not ask you. So in that situation, you should actually they'll actually give you some 5 equations they'll try to give, and you have to balance a chemical equation. So in that process, you have to, the final answer will only have the marks. The process which you actually do will not have. In that case, wherein, for example, this is asked a 5-mark question. So in that situation, each one will actually have 1 mark only. So in that process, they'll not check the process which you need. They'll only check out the final answer. So in that process, it is not required to do the process. You can just mind calculation also you can do. Otherwise, if you are so perfect and thorough, means you can actually do mind calculation also. For example, I'll try to do one more equation. So this is a process. For example, H2 is there. H2 plus O2 will give for H2. That means water is hydrogen and oxygen combining together form water. So here 2H2 you can take, and here also 2 you can take. That is balanced chemical equation. That means 4 oxygens are there. Here also 4 hydrogens, 4 hydrogens. Then 2 oxygens. Here also 2 oxygens, because 2H2 now. So this 2 is actually acting for O also. That is oxygen. And here if you see 2 and 2 are there, that means 2 into 2 you have to multiply. In case if it is like this, then you should multiply it as like 3 only. That means 3 into 2, that is 6. 6 oxygen atoms are there. Here 4 oxygen atoms are 4 atoms are there. Here 6 atoms are there. Okay, so in this process you should actually solve the questions. Okay. Okay, now let's go to the important part. Aqueous is nothing but when a solution is actually in the form of a solution. That is actually when a substance is actually in the form of a solution, that is called as aqueous. Okay. So in the textbook, the different examples given. You can just refer that example also. Okay. And one more important here, I told about the linear method. So for linear method, try to make one more video. Because so this process you will be this thorough, so you try to solve all problems in this method. And if you are so perfect and thorough, means you can do the mind calculation method also. Just here you can just do that method also. Okay. So this chemical equation actually, so if you want to include more information in chemical equation, then you can actually include about the pressure difference also. You can include. You can also include about sunflower chlorophyll. All this is nothing but called as an extra. And if you want to include more information in the chemical equation, you can do that by writing it above the arrow or below the arrow also. You can do that. Okay. So this question, so let us solve quickly these questions. So why should a magnesium ribbon be cleaned before actually burning? Because it forms a layer of magnesium oxide, therefore it must actually be cleaned. Therefore this layer of magnesium oxide will prevent it from burning. Okay, first question done. Second question, H plus so hydrogen plus chlorine, balanced chemical equation. So always hydrogen act as 2 hydrogen, chlorine, nitrogen, oxygen, all these are diatomic molecules. So H2 you should write. Whereas ozone is a triatomic molecule, and sulfur S8. Sulfur is 4. Sulfur is the octatomic. So sulfur S8 will write. Sulfur S8 will write. So in that form you should remember all these kind of things. Okay. Whereas magnesium, aluminium, all these are monoatomic. Means only one. So just Mg you can mention anywhere when you are actually writing the chemical equation. Okay, this one you should just remember it. Okay. The next most important thing. Okay. The barium chloride, barium BaCl2 plus barium chloride, because barium is nothing but it is Ba. So you should always see capital. Okay. So aluminium sulfate. Aluminium is sulfate. Means for example you write aluminium SO4 B2 Al2 SO4 taking thrice. In last year actually learned, right? Al2 SO4 taking thrice. Equation gives rise to BaSO4 plus AlCl3. Okay, let us try to balance the equation now. We'll keep 2 here. 3 we need. 3 if you keep here, 3 here, No balance, no? 3 bariums, 3 bariums are like. And 6 chlorines are 6, 2 to 6, here 6, 2 aluminum, 2 aluminum. Okay, perfect. This is balanced equation. Okay. Next, oh, before equation, try to balance. I forgot to balance. So 2 oxygens, 2 chlorines. Complete a balanced equation. Next, sodium Na plus H2O forms sodium hydroxide NaOH plus hydrogen gas. So 3 oxygens are there, but here only 2 are there. So what we'll do, so try to keep here something. Check if it is balanced. 2 sodiums, 4 hydrogens. 2 hydrogens here, 2 hydrogens, 4 hydrogens, 2 oxygens, 4. Perfect. This is also a balanced equation. Next, this one also you can do BaCl plus sodium sulfate also. This equation is also very much simple. You can try to do these equations. Sodium hydroxide, when it is actually reactive from sodium hydrochloric acid and to produce sodium chloride solution and water. So it does try to take 5 minutes break and I'll come up within just 5 minutes. Okay, I got a call. Okay. Okay, that call is nothing. Okay, you can just So now you got an understanding, right, about the entire process, how we actually balance the chemical equations, how we actually do everything, right? Now the most important thing, right, about how we actually, okay, the most important thing is about what are the different type of chemical equations. Very, very important thing. So it's important from board examination also. Surely 2-3 questions will come from this. Now let us try to understand what is the first reaction that are. Okay. So first we are mainly going to learn about the combination reaction. So what are actually the combination reactions? Combination reactions are the kind of reactions wherein one or more substances actually combine together in order to form a single product. Then that is called as a combination reaction. That means combination from the reaction itself, from the name itself, you can tell that they are actually combining. That means 2 or more products, 2 substances when they are actually combining. That means 2 substances. Okay, 1 or 2 substances are actually combining. So okay, they're actually combined together to form a single product. That is called as a combination reaction. Okay. So combination reaction, you got an understanding, right? So these combination reactions are also very, very important. So if you see the activity 1.4, what is actually given in the activity 1.4? Take a small amount of calcium oxide. Okay, I'll take a small amount of calcium oxide. Please. Okay, so let us try to take a calcium oxide. Let me keep. I'm really sorry. So what are the combination reactions? These combination reactions are nothing but 1 or more two substances will actually combine together in order to form a single product. That is a combination reaction. So here we are, so when we are actually discussing about this activity 1.4, so we are actually taking a calcium oxide, that is CaO, plus we are actually reacting it with water, so that is H2O. So when these both things will actually react together, this forms calcium hydroxide. And this also releases heat energy. So they ask the question, so do you feel any change in the temperature? Yes, we feel a change in temperature because heat energy is actually evolved here. That means heat energy is actually released. Heat energy is released, of course there is a change in temperature from coldness to hotness, right? So yes, there is a change in temperature because heat is actually evolved. So this is an exothermic reaction. So what is exothermic? I'll tell now. Okay. So this is the first equation. See, calcium oxide reacts vigorously with water, produces cyclone, releasing a large amount of heat energy. So the answer is actually given here. You can check, just refer it. Okay. Now let us try to understand the second most important reaction. Okay. That means if you see here also, so two or more substances actually combining together in order to form a single product. That is called as a combination reaction. So about combination reactions, few things are actually given here. So let us actually check them. Okay. First, see how calcium hydroxide is formed. That is very much important. Calcium oxide, when it is reactive with water, it forms calcium hydroxide. Okay. And releases heat also. This calcium oxide is called as quicklime. Important from the examination point of view. What is quicklime? This calcium hydroxide is called as what? It is called as slaked lime. Okay. Then what is actually given here in this table? So in this table, what is it? It is given that calcium oxide, that is calcium hydroxide, is actually used for the whitewashing process. So see what happens. So what is actually used for whitewashing? Calcium oxide is used for the whitewashing because when it is actually put in water, it forms calcium hydroxide. So calcium oxide, that is CaO, is actually used for the whitewashing process. Whitewashing is nothing but, that means in the olden villages also, or during the summer season also, on the rooftop you try to paint it the white color, right? That is called as, that paint is actually called as a calcium hydroxide. Okay. Now what is the reaction they are actually telling? So when calcium hydroxide, so this calcium hydroxide, when it is actually reacted with carbon dioxide gas, it forms calcium carbonate. So before okay, now let me tell you. So this calcium hydroxide, okay, so calcium oxide is there, I kept it in water, I got this calcium hydroxide. Now what happens next? I'll try to take this calcium hydroxide, it is in the liquid form. So I'll try to paint it on the walls. So I have actually painted the walls. The walls are actually painted. After painting, what happens is that, so after 2 to 3 days, what happens is that this calcium hydroxide will try to trap the carbon dioxide gas from the atmosphere. So in atmosphere, carbon dioxide gas will be there, right? So this calcium hydroxide has a capacity to trap the carbon dioxide gas. So it will trap all the carbon dioxide gas and forms calcium carbonate and water. Okay, so calcium hydroxide, when it is actually trapping the carbon dioxide, that is, it is actually reacting with carbon dioxide, forms calcium carbonate. That means after 2 to 3 days, what happens is that we get a shiny substance which is actually formed on the wall. That is called as calcium carbonate. Okay, calcium carbonate is actually formed. Okay, this calcium carbonate is called as marble, or it is called as limestone also. You can call it marble or limestone also. Okay, this is a very, very important reaction. Important question will come from this, means definitely these two things, anything will come. Okay, it can be asked for 3 mark question or a 5 mark. 3 mark question mostly, otherwise a 2 mark question can be asked from this, or else multiple choice questions can also be asked. Okay, therefore if you see, this is an example. So this is an example of what? A combination reaction. Okay. Then next, the burning of coals. So what is the burning of coal? That it is nothing but when carbon, it is actually reacting with oxygen, it is forming carbon dioxide. So this is also an example of a combustion reactions. So combination reactions. Combination reactions are nothing but when 2 or more substances actually combine together to form a single product, only single product. That is called as a combination reaction. Okay, then formation of water also, as I already told you, hydrogen and oxygen react together to form the byproduct, that is water molecule. This is also a combination reaction. Okay, then what are the exothermic reactions? Exo means releasing. Okay, endo means taking, that you must remember. Okay, exothermic reactions are nothing but when the heat is actually evolved, or when the heat is actually released during the chemical reaction along with the formation of the products, that is called as exothermic reaction. For example, as I already told you, if you go up, so this equation it is telling that it is releasing huge amount of heat energy, and this is an exothermic reaction, right? Yes. So if you ask, so just to remember only one example, So if they ask combustion reaction and exothermic reaction, you can just remember this one example. So try to link like that, because from now on you have to remember for everything. Like you have to remember oxidation reaction, reduction reaction. You have to remember endothermic, exothermic, combination. You can decomposition, displacement, double displacement, anything from any of these. An example may be asked in the exam. Then how will you actually remember? Try to link like this. That means combination and exothermic, and you can remember one example only. Okay, like that you actually try to link between the subjects. Okay. In the middle also I'll try to do that. Okay, so that is an exothermic reaction. In the similar process here also few examples are actually given. That means, so when methane that is CH4, it is actually reacting with oxygen gas, it is actually forming carbon dioxide and water. Any substance, any carbon molecule, when it is actually reacting with oxygen gas, forms carbon dioxide and water only, and releases heat and light energy, of course. And very important question, as we already learned about the respiration process. Respiration is also an exothermic reaction because it is releasing heat energy. That means when glucose molecule is actually converted to pyruvate, so when it is actually reacting with oxygen gas, it is forming energy, carbon dioxide and water molecule. Therefore, this is also an example of exothermic reaction. That means energy is nothing but 38 ATP of energy in the case of complete oxygen. In the case of presence of oxygen, 38 ATP molecules of energy is actually released. This is also an example of exothermic reaction. And the decomposition at the breaking down of the vegetable matter into a compost is also an example of exothermic. In that case also energy is actually released. Energy is not absorbed. Energy is actually released in the case of decomposition of vegetable matter. And digestion process, energy is actually not released. Energy is absorbed in the case of digestion process. Okay, so that is a reaction. Okay, now let us try to understand what are the decomposition reactions. Decomposition reactions are kind of reactions wherein we try to break down a single product into two or more reactions. For example, if you see here, if you try to remember like this, combination is nothing but two or more are reacting together. So, see for example, okay, two or more products. Okay, so that means one chocolate and two chocolate are reacting together to form a big chocolate. Combination, that means combining. Decomposition, what is happening? So what happened? So you have two bites of chocolates. So one is for you and one is for your sister. So your sister is not there. So what you have done? You have to. So these two you ate together. That means it is forming a single product, right? That means it is forming a single product which consists of both the A and B products. Okay, right? So this is a very big single product this is forming. Okay, but that is a kind of a combination reaction. But now you have a very big bite of chocolate. Okay, you are actually breaking down. So in order to give to your sister, you want to give you to your brother, and for yourself also, you are breaking into two or more substances. It can be two substances, it can be, or more substances can also, it can, but three also it can be. So in that case, one big chocolate you are actually breaking down. One big dairy milk are actually breaking down into three different parts. It is also an example of. Then this is an example of decomposition. That means one big product is actually divided into three products, whereas combination two products are actually combining together. That you must actually remember. Okay, so remember like this, you can easily understand the reactions. Okay. Now let us see the activity 1.5. So the activity 1.5 is very much important. Okay, so for everything you must remember the colors. Colors are very, very important from this chapter. What is the color of ferrous sulfate? What is the color of copper sulfate? What is the color of zinc sulfate? Everything is very much important from this chapter. Okay, so okay, meeting is ended now. I think it's 40 minutes already. I have to join again. Okay, now let us try to understand this. So 1 minute, I'll try to bring the book in that actually written colors. Okay. Okay, now let us see now. So the reaction of 1.5, activity 1.5 is actually stating that. So what is actually the 1.5 is stating? So activity 1.5, if you see here, activity 1.5. So they are taking the ferrous sulfate crystals. Ferrous sulfate crystals are nothing but it is in the form of crystal form. That means it is a form of small crystals, small particles. It is a ferrous sulfate. Okay. Okay, now then what we are actually doing with these ferrous sulfate crystals? So these ferrous sulfate crystals we are actually heating. That means if you see here, this is the ferrous sulfate. Then when it is actually heated, we get ferric oxide, sulfur dioxide and sulfur trioxide. So these are the different products which you actually get after heating ferrous sulfate. Okay, then what is actually happening? Here heat is actually absorbed. Here we are actually trying to absorb the heat energy. Okay, that you must actually remember. You are actually trying to absorb. So heat energy, so these particles are trying to absorb this heat energy in order to form these kind of products. Then this is an endothermic reaction. Endothermic reactions are nothing but when heat energy is actually absorbed in order to give the products, that is called as an endothermic reaction. Exothermic, it is actually giving out the heat energy. It is giving heat energy. It is releasing heat energy. It is evolving heat energy. Endothermic, it is trying to absorb the heat energy. Okay, that you must remember. Very much important. These ferrous sulfate are usually in the form of a green color. Okay, so this ferrous sulfate, if you see, it is in the green color. Okay, then this ferric oxide, it is in the form of reddish color brown. So reddish, red, brown color. Okay, whereas this SO2 and SO3 are the colorless gases. Okay, and one question will be asked in this. When a substance X, which is in the form of crystals, it is actually heated, it forms a reddish color bar. So when a green color substance, which is in the form of crystals, it is actually heated, it forms a reddish brown. It forms a reddish brown substance, reddish brown oxide, along with the releasing of two suffocating gases. Then you must easily, then so many hints were actually given. So one, it is a green color. So green color means, okay, what will be the green color? Only ferrous sulfate will be in the green color. Okay. Then they are actually telling me that it is actually forming an oxide. That means it is a ferric oxide. And SO2 and SO3 are the pungent smelling suffocating gas. Okay, they are considered to be the pungent smelling suffocating gases. Okay, when you breathe them also, it can cause death to a person. Okay, and these gases are also contributing to the global warming also. So excess of these gases can also cause huge damage. Okay, and this also gives a smell of the burning sulfur. It gives a smell of a burning sulfur. So all these hints are actually given in the question. We must pungent smelling, then write pungent, pungent smelling, then suffocating gas. Must remember from this. Okay, now let us try to understand the next reaction. So that's it. This is not much there to understand. So we are trying to decompose. Trying to decompose means decompose is nothing but trying to break down. We are trying to break down this complex this product to this and this and this. That is ferric oxide, sulfur dioxide, sulfur trioxide. Next, very important reaction, calcium carbonate. So when this calcium carbonate is actually heated, so this calcium carbonate is actually heated, then it forms calcium oxide and carbon dioxide also. So that you must remember. For example, so in the before reaction I have seen the calcium hydroxide. So calcium hydroxide, when it is actually reacting with carbon dioxide, forms calcium carbonate and water molecules, right? But here when this product is actually broken down, it is broken down, it forms this product, that is calcium oxide and carbon dioxide gas. Okay, this you must remember. Very, 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 very important from the examination point of view. Okay. Okay. These two are the examples. Okay. Then in the case of this is this heat energy, when it is and the heat energy is actually used for the giving of the product, that is called as thermal decomposition reaction. So the above two are considered to be the thermal decomposition reactions. Okay. Now this is also thermal decomposition. Here, very important question. Definitely one question. Definitely one question will come from this. What products will actually get when lead nitrate is actually heated? So lead nitrate, if you see, lead nitrate is a white color substance. Okay, and when it is actually heated, if you see the next page, the reaction. So lead nitrate, when it is actually heated, so lead nitrate. So if you see, this is lead nitrate. When it is actually heated together, it forms lead oxide nitrogen dioxide and oxygen gas. Now let us try to talk about this each product, each compound. So this is the white color compound. This is the yellow color compound, yellow color oxide, and this is the reddish color brown, reddish brown gas you'll get, reddish brown. And this is a colorless gas. Colorless gas. Okay, that you must remember. Okay. For example, if you see here also, when lead nitrate is actually heated, it is actually giving some red color gases, right? So that red color gas is nothing but it is a reddish color brown gas, which is a nitrogen dioxide gas. Must remember this, very very important. Okay. So this is also an example of thermal decomposition reaction. Very important. Definitely one question is now. And this lead oxide is considered to be a lethargic oxide. Okay, that you must remember. And this very very definitely what gas is actually given, it is nitrogen dioxide gas, which is in the form of reddish color brown gas. Okay, and this is in the white color. And what is a yellow color oxide, which is actually given, means that is a lead oxide. Okay, lead valency is 2 and oxygen valence is also 2. So because of which 2 will cancel and we will get PbO. Okay. Next, this is a very very important activity. So we have actually discussed all the activities, okay, except the 2 activities which are left out, that also we discussed now. Okay, so we have discussed 1.6 also, that is lead nitrate activity only, and 1.5 is about the ferrous sulfate activity. Okay, this is very very important from the examination point of view. If you see here, this is an electrolytic decomposition reaction. Electrolytic is nothing but we are actually passing the electricity in order to give the products. That is called the electrolytic decomposition reaction. You must remember this, very very important. Okay. For example, so here what you are actually taking, so I'll explain in every. First I'll try to explain the setup. Okay. So here we are taking the battery and we are connecting with the positive and the negative terminal. And we are taking the graphite rods. Why we are using graphite? Graphite is a non-metal, but still it is considered to have free electrons, because of which it is a good conductor of electricity. Okay. Then after that, the oxygen gas is actually evolved here, and hydrogen gas is evolved here. Important from the examination point of view. And we are actually taking the H2SO4, that is sulfuric acid, because it is used as a catalyst. So here actually we are using as a catalyst. Catalyst will actually help in speeding up of the reaction. Okay, so in order to speed up this electrolytic decomposition reaction, we are using catalyst, that is H2SO4, the sulfuric acid. Okay. And if you see here, it is an the gas released here is the oxygen gas, and the gas released here is the hydrogen gas. If you see the amount of hydrogen gas, which is also, I forgot to write the equation, right? So here if you see the equation, so I'll write it above. Right. H2O, it is actually when the electricity is passed, it gives hydrogen gas and oxygen gas. Okay. Okay. So if you see the amount of, so when so hydrogen gas, we are getting oxygen gas also. So hydrogen gas, the amount of, so question can be asked. So the amount of, so which gas is double that of other. So hydrogen gas is double that of the oxygen gas. Why it is double that of the oxygen gas? Because hydrogen, so in the water molecule, hydrogen always exists in the 2 parts as compared to the oxygen, which will exist in the 1 part. Therefore, the amount of oxygen gas which actually reduced is less. That means there is half that of the hydrogen gas. Otherwise, hydrogen gas is, which is released, is double that of the oxygen gas. That you must remember. So what happens in each case and which gas is actually present in each test, you must remember this. So sometimes what they'll try to do is that they'll try to give this entire setup. They'll not give which gas is actually released here or which gas is released here. You must actually see the picture. So here, if it is less gas means it is oxygen. If it is more gas means that is hydrogen gas. So in that process, you have to answer the questions also. So okay. So now let us try to understand about this, which we have anode and cathode also is there. So the few important points I have actually written, so let me give it to you also. Okay. So anode is a positive electrode, okay, whereas cathode is a negative electrode. So anode is considered to be a positive electrode and cathode is considered to be a negative electrode. So what happens here? So cathode, so it is always said that anions, anions, cations, anode, cathode. Anions are negative, cations are positive. Anode is positive, cations are negative. Okay, am I doing correctly? No? Anode is positive and cathode is negative. So 1 minute, I'll try to see here only I mainly get confused here. Anode, cathode, anode. So that is the important thing. So it is always, you have to remember that an ion will always go to the positive one, okay, because always a negative and a positive will always attract together, okay, and negative and positive will always attract together. So anion will always attract to the anode and cation will always attract to the cathode. That you must remember, okay. That means positive charge. So if you see, oxygen is an anion because it has a negative charge, and cation is a hydrogen gas because it is a positive charge. So if you see here, oxygen gas will, let me check here. So therefore what happens, oxygen gas is given at the anode. One important question. So oxygen gas, where oxygen gas is actually given? Oxygen gas is given at the anode and hydrogen gas is given at the cathode. You must definitely remember this. Without remembering this, you cannot do anything. What is anion, what is cation, what is anode, what is cathode, which gas is actually given at what? You must remember. Once again I'll try to explain, okay. So you must remember that anion is negative, cation is positive. So here what is oxygen gas? Oxygen gas is having a valency of 2 minus. Therefore anion is oxygen and cation is that is hydrogen, okay. Whereas when you talk about anode and cathode, it is opposite. So what happens, anion is negative, right, whereas anode is positive, and cation is positive, right, but cathode is negative. It seems confusing, but you must remember this. If you just remember this entire thing, you can easily answer, okay. So you must always remember that always a positive will always attract together. Positive negative or negative will not attract. Positive and negative will attract, or negative or positive will actually try to attract, right? So always what you see, so anode will always, anion will always go to anode because negative and positive, whereas cation will always go to here, that is negative, okay. That you must remember here. Cation will always go to cathode, which is negative, that is hydrogen will always go to cathode. You must remember where the hydrogen gas is actually given means you must say cathode. Oxygen gas where it is given means it is anode. Very important, very important from the examination point of view. Definitely one question can be asked from this. You must definitely remember this, okay. This is an electrolytic decomposition reaction. Now let us see what is a photochemical decomposition reaction. A photochemical decomposition is nothing but when a substance is actually kept in the presence of sunlight, that is sun, it will actually give the byproducts. That is the byproducts it gives. So for example, here we are going to take AgCl. AgCl is nothing but silver chloride. Silver chloride, it is actually kept in sunlight. So silver chloride, when it is normally, it is generally in white color. So when it is kept in sunlight, it is actually turning to grey color, that is silver. Okay. And silver and chlorine gas is nothing. Chlorine gas is actually given, which is something like greenish or yellow color gas which is actually given out. So AgCl is generally white in color, and Ag is a silver is a gray color. Okay, so this you must remember. AgCl, when it is actually kept in sunlight, it is giving silver and chlorine gas. Very important. And similarly, you can take one more thing, that is one more example, that is silver bromide. So silver bromide also behaves the same way. So silver bromide, when it is actually kept in sunlight, it gives silver and bromine gas. So that you must remember. This is a photochemical. So what are the three different type of equations, decomposition reactions we saw? First one is the thermal decomposition. Second in thermal decomposition we saw the ferrous sulfate and calcium carbonate and lead nitrate, which is actually heated. Okay. Then second thing we actually saw electrolytic decomposition, where we saw water molecule is actually broken down into hydrogen gas and oxygen gas. Okay. Then we have also learned about the third thing, that is the what is the third thing we have actually learned? Photochemical decomposition reaction. Okay, that is also very much important from the examination point of view. Okay, now I think you got an understanding, right, about the endothermic reactions. Endothermic reactions are kind of reactions which absorb the heat energy, light energy, or the electricity in order to give the products. Okay, whereas exothermic are nothing, they try to evolve, release, or give out the heat energy or light energy or anything. Okay. Let us solve these questions and more. So much is there, I think, or half an hour, 45 minutes it will take easily. Okay, so X product which is actually used in the whitewashing is nothing but it is CaO. So when CaO is actually reacted with water, it forms calcium hydroxide. So amount of gas, why it is actually more, hydrogen gas is more as compared to oxygen, we have already discussed, because hydrogen always exists as 2 parts in water molecule as compared to oxygen molecule. Okay, so next important thing, this reaction, this part is very much important. Okay, so if you see here, we are actually trying to keep the iron nail. So iron nail is there. So before we actually learn about the displacement reactions are nothing but when a higher reactive metal or a more reactive metal will try to displace a less reactive metal from its salt solutions is called as a displacement reaction. Displacement is not why it is trying to displace, it is trying to change its positions, it is trying to change its ion source. That is a displacement reaction. If you see here, if I am taking a beaker, this beaker I have a solution that is a copper sulfate solution, and I am actually putting an iron nail in it. Okay, I am actually putting an iron nail. You should always remember that a higher reactive metal will always displace a low reactive metal. So you should always remember the reactivity series. That is, I'll remember like this. Katrina, Alto, Zen, Ferrari, Phir Be, hame. Found Milli means mercury. Milli, silver, Au-Audi. Okay, silver, Au-Audi, platinum. Okay, so like this, you should actually create some mnemonics and you have to remember that. Okay, so this is very much important. Without this, you cannot do anything with the displacement reactions. Okay, so first the reaction. So a more reactive metal will always displace a less reactive metal from its salt solution. That means a less reactive metal should always be in the form of a solution. It is in the form of a salt solution only. So for example, if you take like this, Cu plus FeSO4. First you try to tell which is the more reactive metal. Fe is a more reactive metal. Okay, that is fine. Then the second step which is actually check is that whether the low reactive metal is in the salt solution or not. If you see copper is there. Copper is it in the form of salt solution? No, it is not in the form of salt solution. Therefore, this reaction will not take place. This reaction is just a blunder. It will not take place. Okay, like that you have to remember them. So for this, I'm actually very much. I can't express my gratitude towards my chemistry teacher, because she was the one who actually helped me to remember this entire chemistry also, and because of ma'am only I'm able to teach you all chemistry and also able to, and also I actually felt interest in chemistry also. Ma'am classes were just amazing. So with the help of ma'am only I'm actually able to teach also. Okay, so our chemistry ma'am only have actually taught all this entire thing. So ma'am name is Tanu. Tanupreet ma'am. So Tanupreet ma'am. So ma'am actually taught us this entire thing, that is a reactivity series. So words you can remember like this, that is can remember by, so Katrina ne car, Mangi, Alto, Zen, Ferrari, Phir Be, hame means H, Mercury, Cuon, Milli, silver, Audi, platinum. Can remember like this, right? So if you want, I'll try to write somewhere. Okay. So if this video is going to be lengthy, also try to watch it, because it is so useful and so it has a good content also. Okay, I'll try to write it in the next time. Okay, so first you try to see it now. So as you got an understanding, first thing, two things you have to keep in mind. The low reactive metal should always be in the form of a salt solution only. As I already told you, if copper and iron sulfate are reacting together, it will not form a reaction, because iron is a more reactive metal and copper is a less reactive. So copper should be in the form of a solution. But is it there in that? No, it is not there. Then it is not a reaction. Okay. So therefore iron plus copper sulfate, this is a reaction, because copper is a low reactive metal and it is in the form of a salt solution. Then this can be considered as important reaction. And you must remember, copper sulfate solution is always in the form of a blue color. Okay. So as I already told you, I am taking a beaker and keeping a iron nail in that. Okay. So this beaker is actually containing the copper sulfate solution, which is in the blue color. Okay. As if you see that before page also, they are keeping the iron nail in the copper sulfate solution. Okay. After that, what is actually happening? After that, iron is actually getting a coating of brown color substance actually formed on that. Okay, because copper is getting deposited. Copper, generally what is the color of copper? Copper general color is a brown color. Therefore, copper is deposited on copper, and iron, which is actually present on the iron nail, is actually shifted to the solution. Therefore, what we get the byproducts? We get byproducts as copper and iron sulfate. We get the byproducts. Okay, so why we actually getting? Because displacement means it is displacing. Okay, so copper is actually deposited. That means iron nail. So we are getting the iron nail as a copper iron nail, and the solution which is actually there, it is a copper sulfate solution. Sorry, this is the iron sulfate solution. So the solution which was in the blue color before, it's actually turned into light green color solution. That you must remember. Okay, and once again I'll try to write. So if we say iron is generally the greyish color substance, and copper sulfate, it is blue color. Ferrous sulfate, it is a light green. Copper, it is in the brownish color. Okay, this is a reaction. So similarly, zinc is reacting with zinc, copper sulfate to form zinc sulfate and copper. Okay, and Pb also, that is lead, is also reacting with copper sulfate, copper chloride, in order to form lead chloride and copper. And one reaction is actually given in 1.2, as if you remember 1.3 that is. So 1.3, that is zinc, when it is actually reacted with H2SO4, that is sulfuric acid, it forms zinc sulfate and hydrogen gas. Therefore, actually I didn't tell that time because not understand what is actually displacement. Now we actually understood, right? What are displacement reactions? So zinc is actually displacing hydrogen gas. So what is actually that means? If you see, zinc is a enemy. So enemy is actually what is it doing? You think this is the family. So enemy wants to destroy the family. So what it is actually doing is separating hydrogen from the sulfate. Therefore, it is actually removing hydrogen and taking its position. Okay. For example, you can tell like generally what is actually happening is, you see many serials also, what is actually happening, women enemies will be there, no, women villains will be there, right? So this, do you think this is one woman and this is another woman? I'm telling only about the serials, okay, only about soap operas and everything. All the Saas Bahu dramas, the bigger that one I'm actually telling. So this zinc sulfate is actually one, okay, woman, okay, and this is wife and husband. What is actually happening here? Woman is actually in serials only. what will actually happen? It will try to remove wife's position and wants to occupy that position. Okay, the same situation is actually happening here. So zinc actually wants to remove wife from that position. Okay, so the woman wants to remove the wife in order to get control of the husband. Okay, so get control of this man. Okay, so what is happening here? So the zinc is occupying. So the villain is actually getting the man. Okay, and wife is actually left out. Generally, that will not happen in the serials, but this is the example that I actually want to give you, so that you'll actually understand it also. Okay, so let us try to see. Okay, the next thing, that is double displacement. Very, very important. Double displacement. Definitely one question will come. What are double displacement reactions? Double displacement reactions are kind of reactions wherein the exchanging of ions will actually take place. For example, if you see sodium sulfate, it is reacting with barium chloride. It forms barium sulfate and sodium chloride. How it is actually formed? If you see here Na plus NaSO4, Na2SO4, Na2SO4 is there, BSL. So this last one you try to connect with the last one of this one. So first one to the last one, and this last one to the first one. Like that you try to connect. So SO4 and Ba, and Na and Cl. Like that you try to connect. So NaCl. So NaCl is there. So BSO4 and Ba. So try to do like that. Then you'll actually get an understanding, right? You get an understanding. That is the exchange of ions is actually taking place. And these double displacement reactions are also called as precipitation reaction. Why they are called as precipitation reactions? Because a precipitate, that means an insoluble substance is formed. If you see in this reaction, BaSO4 is actually formed as a precipitate. Precipitate is nothing which is an insoluble substance. So these both are white color substance, and we are also getting white color only. So this, therefore, this double displacement reactions are called as precipitation reactions. And if you see the activity 1.2, in 1.2 also this activity also. So exchanging of ions is actually taking place. That is an example of double displacement reactions. Okay, now that you must remember. So they are actually giving one more time. So when you have mixed lead nitrate, what is the formula? Pb. So if you want, I'll write here Pb 2 1. When it is actually reacted with potassium iodide, potassium red Ki, right? So what it forms? It forms like this. It happens. Okay. So KNO3 PbI2. So this is the reaction. So potassium iodide, iodine valence is only 1. Okay, then it is forming KNO3. That is nothing but this is activity 1.2. I am discussing all the activities. Okay, so then potassium nitrate it is forming. Okay, then PbI2. That is lead nitrate, form valence is 2 and valence of iodine is 1. So if you want, I will do. This is not. So activities, all activities are discussed till now, and one last activity is there. After that we'll close this. So what are the oxidation reactions? Oxidation and reduction reactions. Oxidation reactions are kind of reactions wherein the removal of hydrogen is actually taking place. So oxidation, we are trying to add here it is not positive negative. We are trying to add oxygen, remove. That means, okay, I'll write better. Remove hydrogen. Reduction reactions, we're trying to add oxygen. Sorry. I forgot.
8 and 5 minutes. 5 minutes. Adhigana 5 minutes.
So oxygen. So we are going to add. So we are mainly going to add oxygen and remove hydrogen. And in this kind of reactions, in reduction reactions, we are going to add hydrogen and remove oxygen gas. That is a very important thing. So in 10 minutes, we have 10 minutes to quickly complete this one. Okay, this is very, very important. Okay, that is a very important thing which you have to remember from this thing. So the first thing that you have to remember. So the first thing that you have to remember from is that from this copper, when it is actually reactive, copper when it is actually reacting with oxygen, then it forms copper oxide. So copper, which is actually in the form of brownish color substance, when it is actually reacting with oxygen, it forms a black oxide, that is copper oxide. So when this copper oxide, when it is again reactive with hydrogen gas, if you see here, again we'll get back the copper. So this is they may ask you in the question, so how we can actually get back copper from copper oxide? Okay, then you must write. So when copper oxide, when it is actually reactive, copper oxide, which is a black color oxide, when it is reactive. So this is right here, brown, reddish brown, reddish brown. Reactive copper oxide, that is black color. So copper reddish brown, when it is actually reactive with oxygen, it forms copper oxide, that is black color oxide. So when black color oxide, again it is reactive with hydrogen gas, it forms copper, that is brown color oxide, that is brown color, that is reddish brown, and you get water. So they're very, very important reaction that you have to remember here. Okay, then let us try to understand how the oxidation and reduction is actually taking place. So if you remember here, copper oxide is there. So copper oxide. Here copper oxide, it is actually fused. Let us try to link copper with copper and hydrogen with hydrogen. Okay. So if you see copper is having oxygen, here it is not having oxygen. That means removal of oxygen is taking place. Then which kind of reaction? It is reduction. Hydrogen is not. Hydrogen is there. Normal hydrogen. It is getting oxygen. Then what kind of reaction it is? It is oxidation reaction. There's simple things that you have to remember. Hydrogen. Link hydrogen with hydrogen, copper with copper. That's it. Okay. Then one more important thing. What you have to remember is that hydrogen and hydrogen. Okay. I've got this now. Then what you'll do next? Next you are mainly going to do what is actually oxidizing agent and reducing agent. So the one which is actually getting oxidized. So first you see oxidation. So this substance is getting oxidation, right? So that is called as reducing agent. Agent we are talking. So reduction, this substance is getting reduced. So this is called as oxidizing agent. So that is the only thing which you have to remember. If you're not understanding this, once try to go back to the video and once actually check also. That means copper is getting reduced. Reduction is happening. So that is called as oxidizing agent. Hydrogen is getting oxidized. That means it is getting oxygen. Therefore this is called as, hydrogen is getting oxygen, that is oxidation reaction. Then it is called as reducing agent. That means hydrogen gas is called reducing and carbon dioxide is called, copper oxide is called as oxidizing agent. That you have to remember. And in if you see in this kind of reaction wherein both reduction and oxidation happening, therefore they are called as redox reactions. The kind of reactions wherein both oxygen and wherein both oxidation and reduction both are happening, that means it is an example of redox reactions. Okay, let's try to do with this example also. This one. Reduction, oxidation, reducing agent, oxidizing agent. This one also. So this is a very difficult reaction. So this is a different reaction. Let me try to check in Google Lens. So this one was quite different, I saw actually. Then in the compound which is getting oxidized, O2. So here HCl is getting oxidized to CO2. So here in this reaction we are going to see about HCl and Cl. Cl and HCl and MnO2 and Mn. Okay, that you have to see. HCl is getting oxidized to Cl2. And MnO2 is getting reduced to MnCl2. That you have to remember. This is only a difficult reaction: reduction, oxidation. So this one only you have to remember. This water molecule is left out. H and Cl2 and Mn and Mn you have to link like that. This is only difficult reaction that you have. In the entire syllabus, you have only this difficult reaction. Otherwise, all are simple, easy peasy only. Easy peasy reactions. Then the last important topic, corrosion. What is actually corrosion? Corrosion is nothing but, as you know, wherein when actually the substances are actually exposed to oxygen gas and all the different kind of acids, moisture, oxygen gas, different kind of gases that are present in the atmosphere, they'll actually get corroded. That's it. That is called as corrosion. So when a metal is attacked by the substances, all the different kind of substances, when it is exposed to air, water molecules, kind of air, water molecules, what are they? Then moisture, then acids, then different kind of gases. Then that is called, they'll get corroded. That is called as corrosion. In corrosion is rusting is a type of corrosion. So rusting formula, if you want, I'll tell. Fe2O3 dot then X2 XX2. This is the formula of rusting. Let's check here. Fe2O3 dot XH2. That is the formula of rust. So rusting is a type of corrosion wherein the iron particles will get rusted when it is actually exposed to oxygen and moisture present in the atmosphere. That is called as rusting. Okay, they form a brown color flaky substance called as rust. Okay, so this is also a very serious problem. And what is rancidity? Rancidity is nothing but, so for example, some substances are there when actually there some food particles. So when food particles, when they're actually exposed to oxygen, that get rancid. That means their taste and their smell also will change. So and they become spoiled also. They also get spoiled also. Those kind of substances when actually exposed to oxygen, which gets spoiled. That kind of substances, and that process is called as rancidity. So how we can actually prevent rancidity? We can prevent rancidity by adding antioxidants also, which will prevent it from rancidity. So just you have to keep it away from oxygen, but you can't keep it away, no? So you have to keep it in an airtight container, you have to keep it in refrigerator, you have to do vacuum packing also, and all these things, vacuum packing, airtight containers, then adding antioxidants, then keeping in refrigerators, airtight containers, all these things will actually help in preventing from rancidity. Also, it is very much important that so food items, like for example Lay's packets and everything, are actually filled with nitrogen gas, because nitrogen gas is actually helping storing the food items for a longer period of time, then also protect it and prevent it from rancidity. So that is important thing. And this is questions, final in-text questions. So why does copper sulfate solution change when actually iron nail is actually dipped in it? Because displacement reaction is actually taking place. Okay. Then give an example of displacement. Anything you can give displacement. That is, also lead nitrate and potassium iodide gives rise to potassium nitrate and lead iodide. That is also an example of double displacement. And also what is given in textbook also directly. Sodium sulfate, that one is sodium sulfate, and barium chloride gives us a sodium chloride and barium sulfate. Okay. Let us see water oxidized and water reduced. Na is getting oxidized. That is called as Na is called as a reducing agent. Copper, same reaction. Oxidized, reducing agent. This one is getting reduced. Reduction is happening. Oxidizing agent. So these are the only things which you have to remember in this chapter. And the copper reaction, copper, when it is reacted with oxygen gas, it is forming black oxide. When black oxide, again when it is actually reacted with when that black oxide is again reacted with what we say, so when that black oxide also, when it is actually reacted with hydrogen gas, we again get back the copper substance. That is also very, very important reaction which you have to remember. Okay. So all these four important reactions, that combination, decomposition, displacement and double displacement reactions, are very, very important. So hope you are actually chemistry, Tanu, Preet ma'am, for giving us all the knowledge and everything, and for also giving me all the knowledge in order to make this video also. So thank you very much, ma'am. So with the ma'am's help only, I'm actually able to explain you all the different kind of concepts also. Okay. So before I actually end, okay, let me actually try to give you something. Okay. See, that one I told I'll give the reactivity series. So let me give that and I will actually end the class. Okay. So I think you are not able to see, right? I think you can see now. I'll try to increase the font size. K for capitation, that is Katrina. Katrina ne. So Katrina ne car. C is nothing but car. Mangi spelling I don't know. Mangi, I think. Mangi. Sorry, MG, no? MG. So first let's write car Mangi. Auto. Katrina ne car Mangi Alto Zen Ferrari Phir Be hame Cuon Milli is nothing but mercury, okay? Silver Audi platinum. So that's it. Got an understanding, right? So how we actually remember that reactivity series? Try to write it multiple times. So write it 5 times, 6 times, 10 times, then only you remember. Okay? Then only remember it perfectly. Katrina ne car Mangi Auto and Ferrari Phir Be hame Cuon Milli Silver Audi platinum. Okay? So you have to remember. If possible, I try to keep it in the comment section also. Okay? So this one actually was given by my chemistry teacher. So I'll never forget. You'll also never forget it. For the entire lifetime also just remember it like that only. Okay? So that's it. Hope you all got an understanding, right? Actually copied it also, so I'll try to keep it in my video. So with that, let us end the session. So in front of you and I actually kept it. Done. So for that, let me actually end the live stream. Okay. So till then, bye bye.